In this video, we solved problem 10.1.9 from Essentials of Statistics, 6th edition by Mario Triola. The problem statement says use the given data set to complete parts A through C below and use alpha equals 0.05. And we have a row of X values here and a row of Y values here. And in part A, we're asked to construct a scatter plot and select the correct graph from those below. So what I would recommend you do is open this and then click Open in Excel. Now, once you're in Excel, I would select that data, just highlight it, and then go to Insert, and then you can see the images. Here's a scatter plot, so then I'll click Scatter. And I've got my X values on the X-axis. Notice the X values seem to be between 4 and 14, and that's what I see here. And then I've got my Y values on the Y-axis. So I'm looking for something that has this sort of parabolic shape. And I think B is the closest that we have. That looks the same. Great. And then B asks us to find the linear correlation coefficient R. Then determine whether there is sufficient evidence to support the claim of a linear correlation between the two variables. Now, I'm going to do this because they asked me to, but I don't expect a very high value for the linear correlation coefficient R. Because when I look at that graph in part B, it looks like a parabola, it doesn't look like a line. So I don't expect a linear correlation, but we can still follow the instructions and compute the linear correlation R, or linear correlation coefficient R, rounding to 3 decimal places using Excel. Okay, so if I want the Pearson correlation coefficient, the function that I use is just Pearson. So I type equals. Actually, let me zoom in a bit. So I type equals Pearson. And then it asks for the first array and the second array. So you just select those. Actually, I think I select the first array, comma, then the second array. There we go. That's going to work. And then I get an R value of R equals 0.8166, and we want to round to 3 decimal places. So that's approximately 0.817. Okay, great. And then it says, using the linear correlation coefficient found in the previous step, determine whether there is sufficient evidence to support the claim of a linear correlation between the two variables. Choose the correct answer below. In order to do that, we need to look at the table of critical values for our correlation coefficient. And notice that the table of values depends on the sample size. So that's the number of ordered pairs that we have. So I need to count the number of ordered pairs. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 ordered pairs. Or we can use Excel to count the number of ordered pairs. When I look at my Excel spreadsheet, I see that I'm using rows 2 through 12. Oops. So if I wanted to ask Excel to count those rows, I'll say count just the values from here to here. How many values do we have? We have 11 of them. So n is equal to 11. And then I go to my table of critical values and I look for the critical R value for R equals, or for n equals 11. So our critical R value is 0.602. Let me circle that for you. So I'm in this row where n is equal to 11, and then I go to the alpha equals 0.05 column, and I've got an R value of 0.062, and I'm trying to determine whether we have a correlation or not. So the null hypothesis in this case is that there is no correlation. The alternative is that there is a correlation, and that could be a positive correlation or negative correlation. So we actually have 2 critical values for R. They're both plus and minus 0.602. Now, in order to make my final decision, I always like to graph an axis like this. And I like to list the critical values of our sample statistic R along with the test statistic R that we actually got using our sample data. So we use the table, and because we had a sample size of 11, we determined that we had two critical values of R equals plus or minus 0.06 or plus or minus 0.602. So those values are here and here. And then the R value that we got using our sample data, that's our test statistic R, that's over here. That's definitely in this critical region. Now, all of the values of R between the critical values are not statistically significant in the sense that they're not significantly high or significantly low if there truly is no correlation between the two variables. But our values out in the tails are statistically significant. This is significantly high. This would be significantly low. So those correspond to evidence of a correlation. So we'll say since our test statistic R is greater than, let's just say the absolute value of the test statistic is greater than the absolute value of the critical value of R. That means it's farther out in the tails. So we reject the null hypothesis, which means that there is sufficient evidence to support the claim of a linear correlation between the two variables. Even though it looks like a parabola, there is sufficient evidence to support the claim of a linear correlation. And then there's one more question. It says, identify the feature of the data that would be missed if part B was completed without constructing the scatter plot. Choose the correct answer below. Well, it says the scatter plot reveals a distinct pattern that is not a straight line pattern. I think that's our answer. Or the scatter plot reveals a distinct pattern that is a straight line pattern with a positive slope. Nope. The scatter plot does not reveal a distinct pattern. Nope. And last one is that the scatter plot reveals a distinct pattern that is a straight line pattern with a negative slope. That's not true. So I would say A, the scatter plot reveals a distinct pattern that is not a straight line pattern. If we follow this procedure, we might assume that there actually is a linear relationship between the two variables. Because all of the criteria are met, there is sufficient evidence to suggest the claim or suggest that we should support the claim of a linear correlation. But we can tell that a parabola would fit that data much better just by looking at that graph. So it's important to look at that scatter plot so that we can see key features like that. Otherwise, the number crunching may be misleading, may lead us to a misleading result. So we'll say that the scatter plot reveals a pattern that is not a straight line pattern.